Hello and welcome to another edition of TGI Kubernetes. It is Friday again, and this is episode 35. I'm really happy to be back from KubeCon and ready to talk to everybody. So let's get started. Can you all hear me fine? Yes, everything, AV issues, nothing going on there? I'm always worried because, it all works and then I find I talk for 5 minutes and find out that nobody can hear us. So let's say hi to everybody. So we have Mateus, how's it going? Lamati, good to see you. Suresh. Ilya's here. Okay, so I'll talk about, thank you for being with us. Marco, Gabriel, Sean. So Antoine, people are saying stuff. Arnaud, Keith from Scotland. Awesome. Jacob, Joy. Edith, Fabio from Portugal, Florian, Saeed from London, Hamath from Bangalore. That's awesome. Thank you so much for joining us, everyone. Rory, Vinjay, Lucas. Let's see, Engine is in Istanbul. Brian from Denmark. I was just out there for KubeCon. Had a lot of fun. Noah's in Vegas. And then Brian's over in on the East Coast there. Good to see you, Brian. Bob, Florian's in Sweden. Caleb in Arkansas, and Salvador in Spain, and then Steve-O's in Croatia. All right, so it's awesome. I'm always blown away that so many folks are joining from all over the world. It really super cool. So Ilya's on there. So Ilya's one of the folks at WeaveWorks, and he's joining us instead of drinking a beer at the pub tonight because he's based in, I believe, London. And so he's joining us because the topic that we're talking about today is going to be GitOps, and we're going to be looking at WeaveFlux, which is a project that works with the ideas of GitOps. So what I'm hoping to do through this is to define what GitOps is and some of the philosophy behind it. And then we'll look at sort of, what tools can help you do that, which tools can work together here, which tools are a little bit more of a forced fit. And then I'm going to play with WeaveFlux and actually sort of put it through its paces and make it work. So that's the plan. We'll see how far we can get going on there. So Philip from Bonn, Germany, and Gopal from the Netherlands. Awesome. All right, so first of all, I like to do, start out by talking about things that have happened. And there's been a lot happening with KubeCon and other conferences like the Red Hat conference, the Google conference, the Azure conference. So there's been a lot of stuff that's been going on, or at least Microsoft Build, which is not really an Azure conference. But a lot of stuff going on. So yeah, Kris is just down the hall. But she's going to go leave at some point and go climb a mountain because that's what she does. So the first thing I want to talk about is we got some awesome swag. So check these out. So these are custom keycaps that I had made. They're a little bit blurry here. Maybe that's a little bit better. And you can see so these go on sort of mechanical keyboards. And so I spent way too much time researching how these things work. But there's a whole folks who are in the know that there's this whole subculture around mechanical keyboards, old school switches and stuff, and creating custom caps for them and cap sets and stuff like that. So I just had a couple made. Now, these are, I'm gonna educate you all. If you already know this, stay with me. But these are double shot ABS plastic. So double shot means that the actual letter on there, the logo, is actually black plastic. And so it goes all the way through. So it's not an imprint. And so they actually wear really well. And you can see, if you look sort of on the underside, you can see where some of the black plastic is. And so I did a Kubernetes logo and a Heptio logo. And then these are the way that they attach to the switch. This is the Cherry MX stem, and it's probably the most common out there. There's some other ones out there that folks use. And then there's the next thing is the profile. So this is sort of the shape of the key, and there's all sorts of different profiles. These are something that's similar to what you'll find on like OEM sort of traditional keyboards, a little bit shorter. And I made these for like the top 2 rows. So this works well as an escape key or a number key. And so on my keyboard, I have the Kubernetes logo as the escape key, and then I have the Heptio logo as a number 7 key. Oh, I dropped it on the ground. Where'd it go? Oh, it's gone. I'll have to find it later. But but yeah, so they turned out really well, and they screwed up, and like I thought that all of the Heptio keys were misprinted because they actually did it upside down. Our logo is actually directional, even though if you're not used to seeing it, you don't see that. But it looks like it was only half of those, so I still have some of those. So now the question is, how do you get one of these? Because they're super cool. I'm going to be at GlueCon outside of Denver next week doing a talk, and we're going to have a booth there. So I'm definitely going to bring a couple of bags of these along with, so that you can all come and grab one if you're there. Otherwise, we're going to have these at various meetups and such. And one of the other things we're starting to do is, as folks help out on our open source projects, we definitely want to find ways to say thank you to them. And so that's one of the other things that we're looking at in terms of being able to get there. And so Kris says that we're working on a public Heptio conference calendar, so that if folks want to come meet with us and talk with us, we can actually have a place to go where they can find that stuff out. So yeah, so look, the other way is that you can come join Heptio. We are hiring, and so if you do that, we'll even give you a t-shirt, along with a salary. So that's the way that works. All right. So I want to catch up on some of the comments here. So Sean says he has an F5 keycap from when I made for my keyboard since he worked at F5. That's awesome. Yeah. So I don't know, like the Cherry MX stems, do those work on the super old IBM keyboards? I never actually pulled a keycap off. I don't know how far back that standard goes. So yeah. Yeah, and so New York, I think we definitely have some folks in New York. We'll send some off there. Maybe they can take them to some meetups and stuff. So that'll actually be good too. So yeah, all right. So that's there we go. All right. So that's my fun thing. I'm super excited about these. They came out really, really nice, and they feel really substantial. All right. Oh, who's in New York? So we got a couple of folks in New York. Probably Chuck Ha is out there. And he's working on, he's doing some stuff with QADM at this point. And there's some other folks in New York too. I don't want to out him. I think Chuck would be okay with me saying his name on the air here, but others. Yeah. So and this is actually one of the interesting things, and I want to touch on this for a second, is that I do a lot on Twitter. We have a lot of employees at our Twitter. They're doing stuff in open source, and that's great. Not everybody's comfortable being out in front in the public like that. And I know that there's probably a lot of folks who watch TGIK and they really like to lurk, and they don't actually sort of talk in the chat. And so one of the things I want to say is that, like, if you want to come work for Heptio, if you want to get involved in the community, there are ways to do that where you don't have to be out in front. You don't have to be a big personality. Not everybody's comfortable with that. So yeah. So that's why I'm like, there are people in New York, but I don't want to call attention to that. All right. So let me switch to my screen. We're going to go ahead and get started. I'm going to try to get through this stuff pretty fast. So the first thing I want to talk about is discuss.kubernetes.io. So this is something that... Oh, Gabriel, yeah. So, yeah, Kris may take you up on that. This is something that George Castro, who's a community manager for Kubernetes and a Heptio employee, has been working to set up with the contributor experience SIG. And we're looking for new ways to communicate, new ways to build community inside of Kubernetes. So this is an experiment with using Discourse as a forum, as something that's kind of halfway in between Slack, which is super ephemeral, to email, which is kind of old school. We're trying to think, can we actually have something that that is more purpose built for larger communities? So I'm really excited about this, and it's open for business now. So I really want everybody who's on here, I'd love you to sign up and get involved. So it's discuss.kubernetes.io. Let me see if I think I'm allowed to put URLs in this thing. Let's see. So if you go there, is this going to work? We'll see. Oh, wait, no. Okay, so it doesn't show up on the screen, but I don't know if it shows up for the rest of you. Yeah. So I'm really excited about seeing that happen. So I would love to have you all sign up and find ways to start working on this. I think right now this is more general stuff, but I think we'll look to see how we can grow the categories there and really start focusing the discussion. So good job to George and the Contribax folks to actually get going there. I'm really excited about that. So that's super cool. Please sign up. All right, so the next thing I want to talk about, and this was something that was announced at the Red Hat conference recently, is they started getting some more detail, some more meat on the bones on how the CoreOS and Red Hat stuff was going to start coming together. I think this brings some clarity, but also there's a lot of questions too. So I think the big news that everybody's asking about is, I'll get to the operator framework, is what happens to CoreOS container Linux? And the answer there is that they're going to use CoreOS container Linux to as the new sort of way forward. And I don't know what this means for Red Hat Atomic, but I believe this will displace Atomic. They're going to rename it to Red Hat CoreOS. So the actual operating system was called CoreOS, and then as the company CoreOS actually got more serious about doing things beyond the OS, they renamed it to Container Linux. But now it's getting renamed back to CoreOS. So it's Red Hat CoreOS is now the actual OS. But then also as part of that, I'm not a total Linux distribution nerd, but CoreOS was based on Gentoo. There was a huge focus on being as up to date as possible. It looks like they're going to rebase it on top of Fedora, and so there's a lot of folks scratching their heads wondering exactly what that's going to mean and how that's going to work. So it will live forward in some way, but it's not clear exactly what. Now there is a fork of CoreOS called Flatcar Linux? Or flat, yeah. So so this is essentially an open source, friendly fork of CoreOS container Linux that the Kinvolk folks did in Germany, and so they do a lot of contracting. They do a lot of development for folks. Really great group of folks. Lily, who was there, is now at Weave. So they're the ones sort of like also providing a path forward for folks who are using CoreOS. Maddie says virtual kubelets. Yes, I could talk forever about virtual kubelet, or not forever. I could say a lot about it. I'm not sure we have time, but that's definitely a lot of exciting stuff going on about that. All right, so that's that. That's the Flatcar Linux, and then there's smashing together of CoreOS stuff and Red Hat stuff. And then Quay will live on. They're going to open source some stuff around that. So there's a lot in this press release. There's been a few sort of clarifications on Twitter and stuff too. Yeah. Let's see. Videos on YouTube of the talk if you search for Red Hat Summit CoreOS. Okay, so folks can go ahead and find that for more info. I am not the expert. Okay, the other interesting thing that the CoreOS folks did is, or the Red Hat folks did, I'm still confused on why there's still CoreOS.com, and are they going to merge these things together? How does this work? So I don't even know. I don't even know what's going on. But there's the operator framework stuff, which is something that I think has been going on for a while, which is creating an SDK to make it easy to create operators. And this isn't something that I've played with yet, but it's both making it easy to create operators, making it easy to deploy and manage those things, and then apparently there's a metering component that's coming along also. This is super interesting. I think making these things easier to work makes a ton of sense. There's a sort of, academic discussion on what exactly an operator is. To some degree, the simple stuff that you can do with this framework is something as simple as just like having a bunch of parameters that then go ahead and expand using a templating system and get deployed. So there is a blurry line between this stuff and say something like Helm to some degree. And there's even, as part of this framework, there's a way to essentially turn a Helm chart into an operator. And I think if we look at, there's this new, there's, you know, there's the solo.io folks, who they do this glue, GLOO, API gateway thing. They have this Envoy operator, and it's really in that mode where it just like has a domain specific way to deploy this stuff, right? So it's nothing more than templating on top of a deployment. I don't know if that's an operator or not, so I'm really kind of unsure about that. The other interesting thing is, you know, looking at the relationship between something like operators and the service catalog, because if you make it easy to bring up services, you know, do you actually use a CRD that's backed by an operator, or do you use the service catalog, the open service catalog stuff? And so there's a real soup of ideas here, and I think we're still seeing a lot of this stuff play out. Because one of the things you'll see in this operator framework is there is this idea. If I search for catalog, oh no, it's not in there. So they didn't. If you start looking at the actual code, and if you look at the lifecycle manager, there's actually this idea of a catalog that is also driven by CRDs and stuff. So it definitely feels like there's a convergence across a whole bunch of things that have been going on in Kubernetes. And to me, that just means that, you know, interesting stuff's going to come out. So, yeah. So let's see. So I want to catch up on the chats here. Oh, so Jason's joining us. How's it going, Jason? So, yeah. So there's an awesome app operators out there. You know, lots of folks are doing that. So the virtual kubelet, yeah, we should do something on that, or dig into that in some ways. Maybe Kris can take that on at some point. So it's operator-framework/awesome. Yeah. So if you go to the GitHub organization for the operator framework, they actually have a list of operators there. Ilya's like, hopefully this can finally converge. There's 3 operator kits on GitHub. So yeah, and then there's meta control. I love meta control. I think if you're going to do this thing where you like create a sort of a really simple type of thing, I think meta controller is a great solution for that. But it's definitely in some ways in the same vein. So that's some of the stuff going on there. Okay, let's keep moving. So that's the Envoy operator. All right, so gVisor was one of the big things that Google announced at KubeCon, which is really exciting. Now, this has been floating around for a long time inside of Google, and it's essentially, oh man, I mean, it's like it's moving the pieces around. One way to think about this is that it's a more secure container runtime sort of sandbox technology. Another way to think about this is that it's sort of, you know, a hypervisor that's like ultimately para-virtualized, right? So instead of just para-virtualizing the driver, you're actually para-virtualizing the entire kernel. So that's really, really interesting. One of the things that I think is worth digging into here is that if you start looking at the code underneath this stuff, let's see, if you look at the README for gVisor, and you start reading through that, what you'll find is that it runs in 2 modes in terms of the technology that it works. Where did it go? Maybe they changed it. Okay, platforms here. Yeah, so it runs in 2 modes. So one of them is a ptrace sandbox, which means that it does this really expensive sort of tracing of the workload as it runs. And anytime a syscall is called, it goes through, grabs it, implements the syscall in user mode, and then sends it back. So it's kind of like Fuse for everything. And then there's a KVM thing, which is probably, they mark this as experimental, but this is the thing that I think really long term is going to be the place where gVisor sings. So the performance hit for the KVM stuff is going to be a heck of a lot lower. And so this is very similar in some ways to it's a hypervisor, but you know, every syscall turns into a hypercall. So there's essentially no kernel running inside of the VM. So in terms of comparing this with the Linux clear containers, I don't know if they do that. I think there is some comparison to CKAD containers. The big difference there is that with with something like Kata containers, or even like anything built on Linux kit, you're still running a kernel inside the guest. There's a Linux kernel. It has its own file system, its own memory management, its own caches, its own IP stack and all that, TCP/IP stack. What this does is it takes everything that's in the kernel, re-implements it in Go in user mode, and then hosts it outside of the VM, right? So it's really, I think the most similar thing out there, if you want to do some research, is there's this Microsoft research project called Drawbridge that was done probably about 10 years ago now. Like not quite so long, where essentially there's a sort of mini kernel, they call it pico processes, and there's an API boundary, and then that goes across a security boundary, and they only have 45 calls across that. So this was a research project out of Microsoft. I don't think it ever actually saw its way into products, but there you go. Yeah, and so Kata containers, it has a real kernel running inside the guest. The big thing here is compatibility. That's the big question. I think the gVisor folks have been working for a long time to get a lot of stuff running, but there may be subtle compatibility issues there. So yeah, so that's all right. So I'm totally way off topic here, but it's super interesting stuff. Okay, let's keep going. And then the last thing I want to do is that there's a new certification that the CNCF did around application developers, and so this is the CKAD exam, whereas one app and one certification is about how to administer and run clusters. This one is about how do you actually build stuff on top of the clusters. These things are still relatively new, but it's good to actually see sort of more resources out there for this stuff. So yeah. All right. So I am like way into the episode here, but hopefully that was interesting for y'all. All right. All right. Let's jump into GitOps. So GitOps is a catchy term that the Wii folks came up with. This definitely feels like it's an Alexis thing. I don't know, Ilya, you can tell me. Who came up with GitOps? Was that Alexis? It totally sounds like Alexis. And I think it's a great way to describe this sort of this philosophy around sort of where do you actually store your idealized state as you're running applications in a cluster. Alexis, I know Alexis cornered me a little while ago. He's like, I really want to make this phrase happen. I actually think it's a really good idea. But it comes down to this. So like in traditional systems, like in the bad old days of like sysops type of things, what was running on a machine was what was running on a machine. So it's like people would bring up machines, they would configure them by hand, they would run it, and then maybe they'd have a spreadsheet someplace that had an idea of like what should be running on which machine. And then so that spawned a whole industry of this thing called inventory management, which is a total enterprisey thing, which is essentially a way of saying, what the heck's running on all my machines, right? And so it was this idea of, I want to look at what's running, and then I want to derive from that some sort of catalog, some sort of inventory. And so it's like you actually go out and check the shelves to see what's running, and then you record what's actually there. As you start moving to configuration management systems like Puppet and Chef, you move to a world where you still use inventory management, because what you do with Puppet and Chef and Salt and Ansible, what you do with those tools can drift from what's actually running on the machine. And so you have to do sort of a comparison between those things, and it's easy for those things to get out of sync. There are folks who run these things in a very tight loop where they say, hey, I'm gonna run my Puppet run every 5 minutes on my production machines. But a lot of folks, these things can get out of sync. As you move to Kubernetes and systems like Kubernetes, we move to a declarative model, right? So inside of Kubernetes, when you go ahead and install a piece of YAML into Kubernetes as a manifest, you're not saying, oh, please try and synchronize. You're like, this is the thing that should be running. And if there's something running on a machine that's not in the YAML, well, Kubernetes takes care of actually making sure it's no longer running. So the source of truth for what should be running and being able to audit what is running, all that stuff sits with Kubernetes. And that's a huge step forward, because instead of having what's running on the machine's running on the machine, or what Puppet says and what the machine says can be different, we actually have a system that's built to continuously reconcile the desired idea of what should be running and what's actually running. Yeah, so Paul's saying here that some places literally use spreadsheets to manage thousands of servers running hundreds of services. Happens all the time. This is really sort of, the more common than we would ever like to believe, right? So with Kubernetes, we move to a world where the source of truth, which should be running, is in Kubernetes. And that's a huge step forward, because you can still think about inventory management in the Kubernetes world, but it becomes almost kind of trivial. Like, inventory management is like, well, let me just ask the API what's running, right? It's not like you have to go out and grovel around and scrape machines. The API for Kubernetes is the definitive source of what is and should be running. And if you have something running on your machine that is managed by Kubernetes, but the Kubernetes API doesn't report it, well, that's a bug. That's something that we definitely want to make sure doesn't happen. Now, the next problem here is, well, how do you manage the stuff that's running inside of your Kubernetes cluster? And I think this is where things get really interesting, because not everybody agrees on this. And is the stuff running in your cluster, is that your source of truth? Like, if it's running in the cluster, then that's what it should be. And in some degrees, this feels a little bit like the bad old sysops days, right? So if somebody goes into Kubernetes and edits, does a kube control edit and starts tweaking stuff, well, that's the new world, right? That happened. And there are ways to get audit logs on who did what, when, and where. But it's not like there aren't tools built for that. And so if you operate in this sort of declarative mode with Kubernetes as a source of truth, then tools like kube control run really work well there. So you do a kube control run, it creates some stuff in the cluster, it's running, boom, you're done, right? And that model works well with tools like Heptio Arc, because Arc is hey, let me look at what's running in the cluster and being able to back that up and actually restore it. Now, the other way of thinking about this is actually going full declarative, where you manage your manifests outside and then you apply those things, right? And now that's in some ways similar to something like Puppet or Chef or Ansible, right? Now there's this question of well, let's say I have all my YAML, all my manifests checked into a Git repo, and I have stuff running. I still have to go through and actually make sure I take the stuff in the Git repo and I apply it to my cluster. And so that is what a lot of folks are doing, but it's possible for those things to get out of sync. You could have somebody go and edit the thing behind the back, directly. You could have somebody make a change and then forget to push it. And so you end up with this disconnect that can happen there. So let me catch up with the comments here. Yeah, so actual state, yeah. So, John's saying that copy and paste from the Word document into multiple putty sessions. Oh, that's horrifying. All right, yeah, this is like horrifying story time. So some talk about Jenkins. Yeah, so Jenkins is moving in, more in the direction of working well with these systems, which I think is really interesting. Let's see, and then yeah, JavaScript to Excel to automate it. Oh God, Excel is a database. Yeah, and so let's see. So Jason's saying, did Weave put a repo that shows their apply diff pipelines? Well, that's the tool WeaveWorks does it. I don't know if they've actually showed the stuff that what they're actually running in production. I think that'd be interesting. And then Ilya's the fun part is when you extend Kubernetes API with CRDs that do much more. Yeah, so as we look with operators and this stuff, all of a sudden, the set of state is actually expanding dramatically in terms of what we're actually applying and what we want to reconcile. So the idea with GitOps is that you say, my source of truth of what should be running is not the cluster, it's actually a Git repo. And not only is it the Git repo, I don't want to have it be a human operation to take that Git repo and apply it to the cluster. I want it to be an automatic operation. As soon as I submit stuff to Git, things happen and the thing gets deployed. And I think it's also interesting to look at this maybe in comparison to something like Spinnaker. So Spinnaker is a deployment methodology. It both describes what you deploy and how you deploy it. And a lot of times, and I believe last I looked with Spinnaker, the state of what should be deployed actually sits in a database that's part of Spinnaker, right? And for me, that makes me a little uncomfortable because I would rather see the stuff someplace where I can see it and touch it and understand exactly what's going on. And the Git repo definitely gives me that advantage. So one of the other things that you get out of using source control to manage your configs is that you get history, you get code reviews, you get all sorts of tooling that you can build on top of that stuff. So that definitely helps quite a bit. All right, so that's my take on sort of what GitOps is. Now you can go ahead and I'll include the link in the show notes. You can read the post on this stuff that I think Alexis definitely wrote this one that talks about how they work on this. I think so here's the thing. So Sankit says the Spinnaker UI, he loves that. I agree too. I think a good UI on top of this, but I think good layering on this stuff. So the way that you could do GitOps with a good UI is that instead of going through and actually editing Git directly, you can interact with something that then goes ahead and does the Git manipulation for you on your behalf with your name attached to it. So you could build a Slack bot to do that. You could build a UI. But at the end of the day, the source of truth that everybody's operating from and with is a Git repo. All right. So drone with the kubectl kube control plugin to deploy everything. Yeah, I think there's definitely other tools out there that do that. So I don't want to pretend that something like Flux is the only way to go. Now what's interesting is that how you manage that YAML and how you create that manual is a separable process from how you deploy the YAML, right? So there's a lot of things that something like Flux or GitOps can be compatible with. You can do GitOps with Ksonnet, right? Where Ksonnet is a way that you do the templating, you do the expansion, but at the end of the day, you end up with a set of YAML that you apply. Now you can either apply it through kube control or you can apply it through other tools that do it. But the source of truth is actually sitting in Git in some sort of machine readable format. You can use Helm in a mode where you render it client side. You can let's see, there's a ton of different sort of templating solutions out there in terms of how to actually manage and create that YAML. So that's a separable problem. And so I think there's this layering that I'd love to see happen between application definition, application manipulation, and application definition rendering or application. So I'm using application in two different senses here. So there's like your app def modifications. Do you edit files directly or are there other ways? And then how do you take your app def and actually apply it? And so those are all separable things. And the tool that we're going to be looking at with WeaveFlux is that last thing. How do you actually go ahead and apply it? It does a little bit of the app def manipulation around image tags, and we'll see that also. But it's really that last thing that is really the most interesting. So Mateus says that in my previous company, we actually had a Slack bot to deploy Kubernetes, and it would also change the version in our Git repo in the background and push it upstream. Exactly. So that would be in that app def manipulation category, right? Where you have a Slack bot that will help you manipulate your application definition, and then the deploying might actually happen triggered off of those changes, right? So you actually sort of find ways to split this stuff up. So Jason says, can't post the link, but if you search kubediff, it gets you the diffing tool. So is this, so this is a diffing tool that shows the difference between running state and the version controlled stuff. Yeah, I believe there's some other cool tools that are out there too that do similar stuff. Like there's some of this stuff built into Ksonnet also. So there we go. I'll save that here. We'll put it there. All right, so that's GitOps. Now, one of the things that actually gets hairy here is things that like, hey, great, I want to check everything into Git. Oh, what do I do with like secrets and passwords and stuff like that? There's this really cool solution that the Bitnami folks put together called Sealed Secrets. And so this is a CRD for putting encrypted secrets that you may or may not be comfortable putting into source control where they're encrypted, and then the decryption happens after you've actually applied them to the cluster. So it's a way to actually keep your secrets out of your Git repos. Let's see. So I think we need an equivalent of jar for Kubernetes apps. Right now, we are basically compiling .o files and linking them in an ad hoc manner. Unfortunately, Helm doesn't do that. Yeah, so I think there's this whole other, yeah, so being able to create a bundle that contains sort of like a container for your container stuff, right? That includes both this config plus all the other stuff that go along with it. I don't think we've actually seen that happen yet. There's been some efforts there, but we're still pretty early days on that. So yeah, and I'm not sure the difference between the kubediff stuff with the kubectl, diff stuff that's coming also. So yeah. All right, so sealed secrets is really a critical tool for GitOps because it bridges the gap for one of the things that you really don't want to be putting in Git. All right, and then there's the question of how does Helm actually interact with this stuff? And the truth of the matter is that those layers are on application definition and manipulation, and then application app def application, right? Apply. How do I apply my app def? Helm kind of mushes a bunch of those things together, so it actually becomes a little bit awkward. And so there's been multiple efforts to essentially turn Helm into something that can be more declarative, start leveraging CRDs so that it can actually start integrating with systems like this, like WeaveWorks or other sort of GitOps types of things. And so there is this, what is it called, Flux Helm or Helm Flux type of thing there we go, Flux Helm that the WeaveWorks did to start bridging these worlds. Helm 3, which I think we had a pointer on last episode, talked about a little bit, is moving to a CRD-based model that I suspect will be a lot more amenable to the GitOps type of way of doing things. So Valerie says there's been some talk in SIG apps around bundling concepts and what does an app encompass, but it's hard to answer. Yeah, so there's this idea of the app CRD, which is like metadata about an app, but it really doesn't quite get to the fact that I want to bundle all this stuff up. Some of this comes down to the fact that including your Docker images with that bundle can be complicated in of itself from a security signing, registry point of view. So yeah. All right, so all right, and then the last thing I wanted to say is this is just a pitch. It's a thank you to the Weave folks. They have their own Weave Cloud thing, and part of Weave Cloud is integration with the GitOps stuff. So they can provide a UI on top of GitOps. I haven't used it, but I think this actually starts looking at, like, this would be something that sits in that app def manipulation side of the house, right? And also probably gives you some other status on stuff. Oh, look, and it has a picture of Luke. Luke's no longer at Weave. He did this dot mesh thing, which is this really cool sort of Git applied to data thing. So I mentioned that at one point. I'd love to do that in a TGIK episode and play with it. So, all right, so that's that. All right. So that's my setup. Any questions before we start diving into the tool? Hopefully this is a good definition of sort of what GitOps is and why it's interesting and sort of the benefits that folks will get out of it. It doesn't feel quite as immediate and like YOLO, let's get stuff done, but I think in a production setting it really helps. So yeah. One of the other interesting things is that if you're doing manually scaling of replicas, right, I think, what it means is that you're not going to do a kubectl scale anymore. What you do is you go through and you actually change your manifest, you submit it, and then you wait for something like Flux to go ahead and update it. And so that's where you might want to have an easier way to do some of that manipulation so that maybe you can use your Slack bot to actually change that manifest sitting in Git versus having to actually go through all the machinations around Git. All right. Y'all cool for me going on? All right. Let's go ahead and get started. So there is a method for installing Weave Flux using Weave Cloud. And we're not going to do that because I think, that's like I want to stick to the purely open source parts. So we're going to do a manual install of Weave Flux here. And so the first thing I need to do probably is actually clone this directory. And so like all the documentation in the Flux repo is under site here. And I don't know if this gets hosted someplace. Is there like I didn't actually see like a pointer from the README to actually a site where this gets rendered out. So we're going to just look at the markdown in GitHub directly. Most of the instructions here, or at least the installation and setup stuff, assume that you're using Weave Cloud. If you want the standalone stuff, you have to go into the standalone directory here. And we're going to go ahead and start with installing there. But first, I need to clone this thing because I haven't done that yet. And we will do git clone flux. And there we go. Okay. And so, can you all see this? I think we're good. Okay. All right, so we can do, do I have VS Code running? There we go. Okay. So we can look in Flux, and there's a whole bunch of stuff here, but there's the deploy stuff, and that's the directory that matters here for this. And let's look. We have clone the Flux repo and edit the example configuration Flux deployment. This creates all the resource in the deploy directory. Okay, flux deployment.yaml. Okay, so, okay, and then do the rest of it. So let's go ahead. We're going to go through because we're going to install all this stuff. And if you've been watching TGIK before, you will know that I really like to examine the YAML that we're about to install in detail so that we can really understand what's happening here. Okay, so deployment, the strategy is recreate. I believe what that means is that it doesn't do a rolling update. It actually does a down and then up type of thing. So that means that when you update the version of Flux, it'll take Flux down, temporarily. That's probably completely okay for something like this, and it probably helps to prevent, multiple things of Flux sort of fighting with each other. Let's see, there's a secret that gets created and deployed called flux git deploy. We'll have to look to see what's in that secret. And then there's a tempfs used for generating the SSH keys. In Kubernetes, mounted secrets are read-only, so we need a separate volume that we can write to for generating the SSH keys. Okay, and then, and you don't want to write that stuff into some place where it might leak out. You want to be careful with that stuff. And then we have a container called Flux. And there's the tag 1.3. It does some stuff on 3030, and then it maps in that git key and the git keygen stuff. And then we're going to be passing in the keygen path and the, and then there's a URL that we can use called Flux example. So let's go through and so here is an example of some stuff that's running, and we have a hello world service and deployment, and then here's some sidecar stuff that happens, so we can go ahead and play around with that. This runs a sidecar and a master and all that. So, okay, so what we're going to do here is I'm going to fork this because, there we go. I'm going to fork it into, I create my own special thing because I don't want private Heptio repos to accidentally be exposed to the world. So we're going to use this as our GitHub repo that we're working against. And so this is, it's your SSH-based clone thing here. So I wonder if you can use HTTPS here. All right, and then include these next two connect to an upstream service, Weave Cloud. The token in particular is the service. So this is how you can connect to Weave Cloud. So I'd be interested to look to see what that interaction looks like. Okay, cool. All right, so we got that going on. Let's look to see what else happens. So now this is the RBAC-y stuff. So we get a service account. We get a cluster role Flux that essentially is access to everything. So that means that Flux has root on your cluster, something for you to keep in mind. And then those things get bound together. Because Flux is actually going through and mucking with your pretty much doing anything to do a deployment, I think that this makes sense. it might be interesting, to see if there's a way to deploy Flux for a single namespace, because I think I would be comfortable saying, hey, I'm using Flux to actually manage this namespace, but I really don't want Flux to actually have root with kubesystem, right? And doing that sort of everything except that namespace type of thing is not possible with RBAC. So there's no sort of like, hey, this but not that. It really is just additive. It's one of the sort of RBAC sort of limitations. So I'd love to see a way to actually do this thing. Do this thing in a namespace by namespace point of view. What this also means, and I think Helm has some of the issues, is that the Flux, the way that you talk to Flux, because there's this port 3030 here, if that actually is a control port, how is that authenticated, right? Or is that only information? Because if you can actually sort of manipulate things that way, then maybe that's a way of getting root on the cluster. So you got to understand, when you look at your threat model, that you're expanding your threat model by running something like this with root. All right, so then there's a node port. So we have a node port where port 80 is being mapped to 3030. I don't want to do port 80 because that's going to squat on a port that's across a bunch of other stuff. So no, we're not going to do. Yeah, we'll do 3030 there. And the target port is 3030. Okay. And then there's secret. This is the git deploy secret. It's going to start out with nothing in it. And then one of the things, and we'll get to it, is that I think let's start with Flux just doing that, hey, you change git, and then it actually applies it. Another thing that Flux can do is that it can actually look at a Docker image repo, and if there's a newer tag, it can take that tag and then I believe edit git to rewrite the manifest so that it actually. So this is the place where Flux actually plays some of that app-def editor role, right? App-def manipulation role based on watching a repo. And it gets bundled into the same thing, but I think logically you could think about that sort of, hey, watch for updates to the image tags as being a separable thing from, okay, now I want to be able to apply this stuff. So this is mem. But that thing is doing polling, and so as it does it, it wants to actually store its state, and that's where the mem cache here is. So there's a service and a dependence around that. And then let's see. And then when we look at the deployment, Replica's one. So there's going to only be one of these that's running. Now the other interesting thing here is that this stuff is all. Nothing here says which namespace this is going to be deployed to. So by default, this will get deployed to the default namespace because that's what I have set up. So let's go ahead and do that. So Flux deploy, or we go back here. Okay, so we'll do kube control apply -f. So we do this. If all goes well, it'll actually sort of do them in the right order. Yep. Oh, it didn't do them in the right order because it created the deployment and then the secret. Well, you know why it didn't do them in the right order? This is interesting, is that most of the times when folks reference secrets, it is actually mounted as a volume. Oh, it'll get updated, so that should work. Okay. So Ilya says, non-SSH auth options vary so much, we don't support it yet, as there isn't a common denominator. The reason we do image updates is that if you were to do just git reconciliation, you'd keep making PRs to update the image. I'm okay with that, to be honest. I think this is probably like sort of, arguments about, is it true GitOps when you have state that's actually existing outside of it, right? And so if, in my mind, like you should be able to use, you should be able to go to the Git repo and apply it directly. Let's say that Flux breaks, you should be able to go to that Git directory, and if you have the right permissions, apply it out of band from what WeaveWorks is doing. And I think when you're in firefighting situations, and this is not something I'm sure that if Flux has or not, I might be in a situation where I'm like, whoa, things are broken. I want to go ahead, tell Flux to freeze because I need to fix some stuff. And then I'm going to go through and actually manually manipulate some stuff so that I can actually get things up and running. And to do that, I want all the state of what should be running or the last thing applied to actually be sitting in the Git repo. So in my mind, actually going and doing the Git updates would be the right way to do this stuff. So it also ensures that the image gets deployed is actually in the registry. I think that's a good check also, but I would view that as a deployment pre-check, right? Of like, hey, before I deploy, I want to actually go through and make sure that it's actually in the registry. Okay, so Ilya says you can freeze objects with annotations. Okay, so there is a way to actually do that by the objects. I would have a config thing that says, because anytime you have these automatic systems, they're incredibly powerful, but that power can be used to destroy also. So I would love to see in a system like this, the big red button, right? If something's going wrong, I want to make sure that everybody calms down while we figure out what's going wrong. So yeah. Okay, cool. So, but let's go ahead and play with it. I think, these are all opinions. I think the general sort of gist of how this stuff works is consistent across these things. All right, so we got stuff up and running. There's a detailed description. We went through a bunch of that. Whether or not you have RBAC. I'm glad to see that RBAC is the default here, at least being RBAC aware. Okay, to make the pod accessible to the command line client Flux control, you will need to expose the API outside the cluster. A simple way to do that is to use port forward. I love me some port forward. This example here uses some kube control magic to try and get the name of the pod so you can do a port forward. With folks who've been watching this stuff, okay, Ilya say, yeah, the big red button is to actually scale it to 0. Yeah, but that applies. But that's not something like if we think about multi-team clusters. In a multi-team cluster, right now, the way that Flux is being installed, it actually works across all namespaces. But you may want to actually like you're not, are you going to give all application developers the power to actually go ahead and delete Flux, right? Because you have to think about like, do I have the permissions to say, turn Flux off in my namespace, right? Because this is my team's main namespace without impacting other people that are perhaps running on the same cluster. So I really like to think about those things in terms of like, how do things look as we move towards multi-team clusters? All right, so this is the voodoo that you need to do to be able to actually pull out the name of the pod that got created from the deployment. But folks who've been watching will know that with kube control version 1.10, you can actually do this. It's built into port forward to be able to do this stuff, which I am incredibly excited about. So we'll go ahead and we'll get to that. I don't have Flux control yet, fluxctl. So let's go ahead and I'll download that. Flux, so that is fluxctl for Darwin. Yes. Okay. So I want to copy link address, curl. So having a brew formula here would actually really, really help. And you have to always give these things an LO. So the L says follow redirects, the O says save it based on the name that it gave it. And yeah, so brew would be really cool here. But there's a certain amount of steps here, just Ilya, so feedback that are left as exercises to the reader, because most users won't know, and I don't know if, and I see this as a stumbling block a lot of times when I look at stuff, is that you're like, hey, just download the latest one from GitHub. Well, I just did that, but, move flux control, I'm in the wrong directory. Seeing how to do it with curl, and then I got it, or maybe it ends up in your downloads if you click the link. But now I have to do a chmod plus x flux control on this thing, which is like the number of users that know that you have to chmod this after you download it is going to be even smaller. And I'm going to rename this stuff. And then move And then you have to move it to someplace in your path, otherwise you're going to have a bad time, right? So like all those little things actually get complicated for folks. So I think having some better instructions there will help, or doing the Helm chart stuff. For KS, the Ksonic client, we use GoReleaser, which is a really cool project that helps build up Helm charts. So yeah, so now I have Flux control, but it doesn't know how to actually talk to the Flux service. So I need to do this. Well, I can do, first of all, let's do kube control get pods. And we're running the default namespaces. Here we see we have Flux, right? We can get deployments. And we can go ahead and do that. And what we can do now, and this is the cool thing, is we do kube control port forward, and you can do deployment Flux, and then we say, and we'll run this stuff in the background like this. So there, boom, we go. And what it actually did for us is it went through and it actually chased down the name of the pod and then acted as if you had specified that instead. So this deployment / Flux is a way of saying pick a pod that actually talks about that deployment. One of the things it does not do, just buyer beware, is it does not reconnect if that pod disappears. So if you're like talking to a deployment and you actually do an update, you're going to have to stop and restart the port forward command just like before. But at least now you can do that in an automated way without having to actually do some of the sed voodoo that's going on here. All right, so we got that up and running. Oh, and then I have to go through and do this stuff. So we export that, and now I can actually do list controllers. Okay, so there we go. We got stuff going on. Let's see. So, I can't make my screen bigger because you guys can't see that. So I can make the font just a little bit smaller. All right. So, and I'm sorry, we folks are running Calico in this cluster. All right. So that's cool. So Flux control. If I just run that, there's automate, deautomate, identity, list controllers, all sorts of stuff here. This identity is the way that Flux talks to the Git repos, right? How does Flux control talk to the Flux daemon? So one of the things that I always get concerned about, and again, this is thinking towards multi-team, how do I go through and like if I go through and actually do a mutating thing here like this automate and stuff like that, or manage policies and stuff like that, lock a control. How do I and maybe this lock ends up being the equivalent of the big red button. But how does this actually get authenticated? How does it work in a multi-team process? I think without a good authentication story between the client and that daemon, I worry that this has a lot of the okay, so it goes over, well, no, because we're doing port forward, so we're actually talking to this thing directly. So it's probably not going to, maybe it goes over a WebSocket, or maybe it uses gRPC there, but is it authenticated? And that's the question in my mind. Because, this isn't quite as powerful, I don't think, as Helm. But yeah, okay, so lock turns into an annotation. Okay, well, we'll go ahead and we'll take a look at this stuff and we'll go through the examples. But I do worry a little bit about exactly how this stuff works. And it could be that these things actually use your credentials from kube control to be able to talk to this stuff. So it may not actually be talking over that. I'd love to see the API between Flux control and the Flux daemon and understand sort of what the risk profile is if that thing is not authenticated. All right. Boom, boom. And we're not doing the Helm stuff. So, all right. So now connecting to the Flux, we did this. So you can use node port, like they have all sorts of different things, but we got it working now. Okay, connect Flux to a repository. So we did this by the git URL. Oh, and we didn't do git branch, but I assume it takes master in the Flux deployment manifest. And then add an SSH deploy key to the repository. So allow Flux to generate a key for you. So that's what we did. The the flux log should show, oh, we can do flux control identity. Okay. And then this outputs, oh, I didn't get the pretty sort of thing going on there. I just got the key. So we can go ahead. So we got that by talking to the daemon. We got the identity there. Okay. So we can take, so now what we do, and again, it'd be great to see this stuff be super duper explicit. And then the public key will need to be given the service host in the Git repository. So, okay, so create a deploy key in the repo. So we're going to go to our repo here, and we'll do settings, and we'll do deploy keys. We'll add a deploy key. And, oh, so one of the questions is, do I need to allow write access when I do this stuff? I guess we can go and see if anything breaks. The Flux log should show that it has now connected to the repository and synchronized the cluster. When using Kubernetes, this key is stored as a Kubernetes secret. You can restart Flux and it will continue to use the same key. Okay, so we're gonna go ahead and do this, and then we're gonna look a little bit under the covers. So okay, so now I added that. So it's a read-only thing here. Oh, and it was last used within the last week, so it already started using the thing. Okay, so yes, we do need, so it does, wait, so it does actually, okay, so what you're saying is it does write back into Git, it just doesn't go through the PR process, it just like slams in the new thing, right? I think, is that what you're saying, Ilya? Yeah, okay, so let's go through, and I'm gonna now delete this, because, okay, I guess I can't, you can't edit it after the fact. We'll do that, we'll do a lot, and we'll do flux key here, so we have to do that and recreate it, but okay, now we're good. Okay, so it does, okay, so I think we're on the same page then. So it does manipulate Git, so you will see it in your Git history. It just doesn't go through the rigmarole of a formal PR process here. All right, so it went through and it did that. And okay, and now if we do kube control get secrets, what we'll find here is that here's the, so we have the service account tokens, and then we have this thing here. Now I'm going to flash this on the screen, and I'm going to make a plea to y'all. Please do not go through and start vandalizing this Git repo. Now this is going to be more than just typing a simple password in, right? You're going to have to take a lot of effort to like capture a screenshot and do this, and I'm going to delete this repo after it. So those watching at home, don't make me have to recreate this stuff, all right? So don't mess things up for us here, all right? All right, so if I do kube control describe secret, this thing here, it does the identity thing. All right, so then, and then, you know, but if I do a get, so we just have an identity. Now, what is this? This is, we had a PR mode in the past and may come back. Yeah, I'm cool with this not having PRs and stuff. But it is interesting. Maybe the PRs could actually be part of a manual flow. Yeah, nobody start. Come on, guys. We'll see what happens. Okay. So this is actually a big, obviously, base 64 encoded thing. So we'll do to base 64, not 64 dot, was it D? Okay, and so this is actually contains the private key, but where's the public key stored? That's the RSA private key. So like you guys, okay, identity is the private key. Okay, so it stores that in there, but where's the public key get stored? Does it derive? Is that embedded in there? I don't think it is, because that's just an RSA private key. But maybe in a config map? Because it's not secret? What do we got here? So we have Flux, we have pods, we have, when you do get all, it doesn't actually tell you the type. So that's got to be the, replica sets, and then there's like, it's derived. Can you actually get that? Okay, I didn't know. I thought you had to, I don't know. That's a good question. Let's do a quick Google. Get public key from private key SSH. Oh, there we go. You can do SSH keygen of that thing. And then, okay, so it is embedded in there. I didn't think it was. Look at that. Okay, learn something every day. All right, so okay, so by storing the private key there that I flashed on the screen, everybody be good. I don't want you typing like, you know, all like 2K of that. But by storing that, you can actually get the public key. So I assume what I do when we do flux control identity, what this is actually doing behind the scenes is actually making some sort of network call to the daemon. That daemon is reading the secret, deriving the public key, and then putting that out in a way that we can copy and paste this up to GitHub. So cool. All right, so we got it talking. We got it. All right, so we are making progress here. All right, so what do I do now? Okay, I think what I do now is I'm done with the standalone instructions. So I go, and if I were installing it with WeaveWorks, it's like set up flux control and run the daemon. So we do that. All right, so now here we go. Yes, using. We're at using. Okay, well, this is confusing because it says set up flux control and run the daemon, but then it goes to using, and that doesn't talk about it. So the instructions are a little bit off. Yeah. Okay. So there's a little bit of nomenclature here that may be unfamiliar to folks. So Flux apparently calls any of the things that sort of manage deployments for you, like deployments, daemon sets, stateful sets, cron jobs. They call those controllers. It's really sort of controller definitions or not, controller instances, controller manifests, but like controllers for short, which is different from like an actual piece of code that's implementing a controller. So the name controller here is a little bit confusing for me. What we can go through is we can list controllers. And here we can see that hello world. It's able to do this. It pulled this from, is it actually running? Cube control get pods. Oh, hello world's already running. Okay, so it looks like by default, it'll like read stuff from GitHub and actually apply it. So the act of actually adding that key meant that Flux could actually go out, read that manifest from GitHub, and then actually, actuate it, make it happen. So I can go through and do a kube control. Let's see. So let's do kale flux. Kale. Okay, so this is looking at too much stuff. I can do command. So what are the commands? I don't know what the commands. Help, run, version, display logs. Kale run, and then we can do deflux. So, that doesn't actually show me the latest stuff, but okay. So we're gonna go through and we're gonna leave that running here. Actually, no, I'm gonna run it down here so that we can see. Oh, sorry, this is not connected to my cluster setup. Keep configs. There we go. All right, so there we go. So we're going to leave this running. So that means that anytime the Flux stuff actually does something, we'll actually see the log output in real time here. All right. Well, okay, we'll see that. Okay, cool. Yeah, cool. All right. So now we have so now we have this running. So that's awesome. So now we can also do list images here, and we can see that each of these things, there's different images, and right now the manifest is pointing to master A00001. And then there's dates associated with these. I didn't know, I guess each of the tags, there's metadata about sort of when that stuff was pushed. oh, look, we can see Flux is like, hey, I'm checking to see what's going on. There's like a sync loop going on. Okay, so we can see the logging going on there. For those that don't know, Kale is this cool tool that actually does tail of a bunch of pods at once and actually helps you to show them all sort of in context together. So it's sort of a better Kubernetes logs. Okay, and then releasing it. Okay, so inspecting the version of a container. So we can go ahead and we can do that. And then we can now go ahead and update a controller with the release subcommand. This will check whether each controller needs to be updated, and if so, write the new configuration to the repository. Okay, so this is actually going through, checking the thing, and then doing an update to the latest and greatest version. So we can do flux control release, and we can just say, hey, you know what? For this controller, update all images. And so my name's not Phil. We're going to do TGIK. And then you can actually have a message here and all this stuff. So I'm going to go ahead and do that. And then what we're going to see here is that there's a releaser. It's doing its thing. Well, we got a lot of stuff going on here. But now it's saying, oh, I've updated to the latest version across all these things. And then it committed back to the Git repo. That's going on here, and so we can see that there's some fun stuff going on here, and then and then what we're going to see, and then it pushes it. So now if I do kube control get pods, what we can see is that the hello world ones have been updated, and they were updated as of 22 seconds ago. And then if I go and I look at the repo that I cloned. Yeah, so the other thing that you guys might want to do in your instructions here, Ilya, is instruct people to fork that repo so that they can get the full rewrite experience to it and actually point them to that example repo. Because I think I've seen when I've been playing with tools, if they have some example, like an example repo, which I think is a great place to start, and they actually have a tutorial that uses that, it makes it much easier for people to play with this without having to actually think about how do I apply this to my stuff. All right, so then if I go through and if I look at the commits here, yes, here we go. So here we have a new version and it was done by WeaveWorks, which is the user there, and it just pushed this thing in using the key there. So and I think, can I get like more details about this commit, like more metadata about it? But okay, we can look at that later. But what you can see is that it went through and edited the manifest to actually write in the new version of the YAML, which is definitely very cool. So one of the things that I'd love to do here, and I think, and we haven't done an episode on KSON, and I think I'm going to definitely have Brian do something very soon on that, is that if you're using a templating mechanism, you may find that your source of truth is not necessarily the YAML. Your source of truth may actually be the templates that generate the YAML. And so having a plugin model with Flux so that you can actually work with it to figure out, well, how do you list what they call controllers? How do you list the images that are in the controllers? How do you do updates? Still having those things written into Git, and maybe having sort of like a local Git workspace for those tools to work. But I would definitely look at like, how do we actually start supporting an extensible set of templating tools and such that work with something like Flux. I think this is especially important as folks look to not just deal with a single cluster, but lots of clusters, lots of applications. That's where this stuff really gets tricky. Okay, so this is really cool though, because it actually went through and automatically said, hey, let's go find the latest image and let's apply that into the manifest. But yet I can still go to this repo and look and see, here's the latest and greatest of what's going on here. So that's super cool. All right, very cool. Let's see what the Hello World application does. I didn't even know what it does. So kube control get service, and I can do, and the Hello World application, there's a port 80 there. So kube control, port forward service, hello world. And remember, this is just picking one pod out of there. It's not really connecting to the service. 80, 80 to 80. Okay. So let's see what they're, port forward, hello word, There we go. Okay. Now I can do localhost 8080. Ahoy! All right, there you go. So that's the hello world just says ahoy. All right, cool. All right, so we got that up and running. Okay, so that's our application now. All right, let's see. So the next step here would be turning on automation. Automation can easily control within Weave Cloud by selecting the Automate button, or you can do it with Flux Control. So now what I can go through is I can automate. Now, what does automate mean? I believe, I'm going to guess that automate means automatically update when you push a new image versus having to manually do it. But it's not clear exactly what automation here means. Okay. So we can do Flux Control automate. Will automate the hello world thing. And this again, so this is interesting. This is going through and working through that Flux daemon. And okay, and then the way that it does that is it adds an annotation here saying automated is true, which is really cool. So it actually goes through and even for things like like annotations, it does that loop where it writes it into the Git repo, and then there you go. The paragraph below, okay, so David says the code block describes what automate does. So maybe so it says, we can see that list controller subcommands reports that the hello world application is automated. Okay, so here we go. Flux will now automatically deploy a new version of a controller whenever one is available and commit the new configuration to the version control system. Okay. Now does this, I guess that only applies to things, okay, so Flux will handle all YAML that's there, any YAML it finds, but a controller is a special type of YAML manifest in Flux speak that actually has container images in it that it needs to update. So there's nothing going on here with the service stuff either. Okay. All right. So now I can go through and I guess, if you wanted to do a demo where you were pushing your own images and actually shows how it catches that, then you would have to, then you would have to have a different, have a different repo. Okay, so I don't think we're not gonna set up the special repo there. But okay, and then you can turn off automation too, and then rolling back a container. So rolling back a container can be combined by, so like if you want to do a rollback, you can do the Deautomate and the release to deploy the version that you want to roll back to. Yeah, okay. This is interesting though, because I think to some degree there's a subtle interaction here, because I would almost expect that a rollback would be something like a revert in Git, right? So if you go directly to Git and you roll that back, you would do that. But if you're using this automation, there's a good chance that the automation will actually go through and undo your revert if you actually do it in Git directly. So you don't necessarily want to use the Git tools here. You want to use release to actually do a roll forward to the previous version. But if you do the revert and you still had automate on, so let's say that you turn on automate, you then go through and do the it does an upgrade, and then you want to do a rollback. Well, you still have automate on, and so you don't actually see a version of the manifest that has automate off plus the old version, right? And in my mind, this is a little bit of a downside to using annotations here versus doing something like a CRD or a config map for the Flux configuration. Because if the Flux configuration itself were stored in a config map, then that would be a separable object, and you could do something like turn off automate that would impact one object, and then you could do manual control and roll it back using like Git tools to actually go to the old version, right? So there's a certain elegance to actually using annotations here, but it also seems like it's a little bit overloaded because it's not actually part of the deployment. It's metadata about how Flux interacts with the deployment. So anyway, so let's go ahead and do that. We'll give this a try. So we can go through and we can go, and if we do, let's see, we can look at the images. We can also do Flux list controllers of flux control. Okay, here we see automated shows up there. And it looks like it's automated. If you're automating a deployment, then it's automating all of the containers in the deployment. So you can't say, hey, I want to automate this container, but I don't want to automate this other container. So it looks like it's an all or nothing there. So I like this view here. This is actually really cool because it shows all the images in sorted order, and then it points to the one. I do imagine, though, that at some point this could actually get to be a really, really long list. So I wonder if there's something like past like 10 of these, you just do like a ... or something, because that could totally get out of control. Okay, and then we can deautomate. So what's going to happen here is that this is going to actually do an update to the Git repo and then do a redeploy of that thing with the new annotation. So there we go. The other interesting thing here is that we're using an annotation to actually do something like record the policy, but we also have another source of truth, which is actually the Git repo itself. So it might be possible to have sort of a flux.yaml or something like that that's sitting in the repo that never actually gets deployed to the cluster, because who cares? That's actually, that source of truth is in there. But what that would mean then is that when you do like the Flux, list controllers and stuff, it would have to merge those things together. So it would have to look at two pieces of data there. So that's interesting. Okay, so there we go. So that thing is actually now running, and then you can go through and we can go through and we can say, let's roll back to, update image to that one, and it'll update one image, the master image, but not the other image. Commit pushed, and then it's actually commit applied. Okay, so I love this. So commit pushed and then applied. So you actually see that stuff happening live there. And because this is a controller type of loop, if Flux crashed after it did the commit before it applied, the next time it came up, it would actually go through and, not saying that Flux is crashy, it would actually go through and reapply the stuff. So that's actually using the controller patterns that are so common in Kubernetes. And here we can see that we actually get a real good log of all the stuff that happens. So this is all the goodness that comes along with this stuff. Very cool. Okay, let's go through and we can do that. And then, okay, yeah, and then if we do the list images again, we'll actually see that it moved the marker back here versus the latest one. Now it's interesting also that the order of these things is based on the time that they were pushed, not based on sorting the tags themselves. And so, yeah, this is interesting because, let's say that you had, if you, and this would be another interesting thing. I wonder if this would be something that would be a good addition to Flux, is having Flux be Semver aware with the tags, and so you can say, hey, look, I want to be on the latest version of 1.2, but I don't want to be on the latest version of 1.3 of whatever utility that you're doing. Because you do have this situation, you see this happen all the time in GitHub releases, where GitHub shows releases based on date order that they're applied. And when you have multiple branches, sort of Semver type of thing, where you maybe have a pre-release type of thing and whatever, and you're doing that with the same set of tags, then the same image stream, same repo. Order based on time is not the order you want. You want that thing to be sort of Semver aware. And then that would be another piece of metadata of hey, look, I want to automate, but I want to automate within this sort of selector of ranges that would, again, be Semver aware. It starts to look a little bit like, dependency specifications in something like NPM, package.json type things. So that's cool. And then you can lock the controller. Okay, so here let's go ahead and we can lock this. And I think what this means is that locking a controller will stop manual and automated releases of that controller. Changes made in the file will still be synced. So, okay, so when you're, okay, so now if I do the lock, I'm a little bit confused here. So what's the difference between lock and, so it says changes made in the file will still be synced. So this went through and this probably added another annotation here. Okay, and this says locked. And it actually says, okay, here's who locked it. Well, this is cool. When I did the lock, it actually recognized who did it. I wonder why it doesn't actually use that in the commit messages when it's doing other stuff too, right? Because I would, if Flux actually knows who I am to be able to say the lock, why didn't it do that when I actually did this new version thing here? All right, well, okay. So, so now we can do new. Now if we do new version here, I'm getting an error, and I think I'm getting an error because it's locked. Okay. So Ilya Z, yeah, full Semver awareness would be very nice. That means changes committed by a person. So okay, so if you went through and you actually edited the file in Git, it would actually go ahead and do that. So let's go ahead and do that. So we have this image. Let's take this one that we want to do. That one. I'm going to go here, and we're going to, like, we're going to take the deploy here. I'm going to edit this, because this is how I roll. I'm going to go ahead and do that. Is that the right? That's for the hello world one, not the sidecar. Says YOLO. Okay. To commit directly to master branch. And now what should happen. Okay, so so this is interesting. So there's no, a lot of times when you do this type of stuff, you want to set up a Git hook, right? So that as soon as you make changes, it goes ahead and updates that. I don't know, is there a way with Flux to actually set up that Git hook so that it actually gets notified as soon as possible? Yeah, so I think that'd be interesting. So I got an error here, so it's no changes made in repo, and that's because the thing was locked, I think. Okay, so there are Git hooks, so that's a sort of like more advanced config, so that you're not, because right now you're falling back on polling to be able to do this. And it would be cool if I could do sort of a flux control. Is there a way? And then I'd also love a command which is just like sync right now, like actually, go ahead and run the syncs for both the images and everything. So that's good for demos, right? Because it's like, hey, make it happen right now. So it's sort of a forced sync right now, so I'm not sitting here waiting. Because I think I saw that at least with the GitHub repo stuff, it was like a 5-minute sync time. Here's what we're going to do to actually make it sync faster. Kube control get pods is we're just going to kill Flux when it restarts. It'll probably do a manual sync. Boom. And then it comes back up. It says, getting unlocked, automate, get repo not ready. What? Why does it say get repo not ready? I wonder. Did I screw something up? Sync, polling images, get repo not ready. What did I do wrong? Did it recreate the key for some reason? Okay, kube control edit and reduce the interval flag. Okay, so we could do that too. Well, let's do flux control identity. An error occurred. Oh, you know what I need to do? I need to do this. So this is the thing. So I rolled that thing. I have to redo my port forward. Now I can do connection. Get pods. Whoa, I think I might have screwed something up. I killed Flux and it didn't come back cleanly. Connection refused. What's going on here? I'm sorry, I did something off script, Ilya. I didn't mean to. I thought it would be safe to actually kill the pod and have it be restarted, but it looks like something is really confused here. So I don't think we can do an unlock because like we can't even talk to the API server right now. To the Flux daemon. So it's kube control get pod. So let's go through and we're gonna, let's delete that again and see. So it's stopping. And we should have it come back up. So it's not able to talk to Git anymore. No upstream URL given. Cluster, oh, that's the upstream thing. I think it may be cloning the repo, recloning the, so maybe it takes it a few seconds to actually get itself going. Sorry, I went off script, man. Hopefully we can get things working again. Should be, so but I'm still getting connection refused there. Oh, do I need to? Do the port forward and then, yeah, let's do the export again. I shouldn't have to change it, but I did redo the port forward. But for some reason, it's not working. And you know what I'm seeing here is that the, okay, you know what? Do I have? Oh, you know what? I did the wrong port forward. Sorry. That's my mistake. Okay, so this is all me, because I did the one when I was trying to talk to the hello world. So there we go. Now we got that going. And now I can do flux control identity. Okay, and we got that up and running. And this thing ends with 3P. I don't know. Like let's see. So now if I do a, now the question is though, it still says get repo not ready, and I'm not sure what that means. But if I do a settings in my repo, and let's add another deploy key, just because I don't know if maybe it changed the key. Maybe there was a bug and it changed the key. No, that looks like that was the same key, because otherwise it would have actually done another thing. So the key is still right. All right, well, oh, okay, so it's locked now, so maybe the lock is preventing it. So maybe the lock means that it doesn't even sync the files also, because let's try and do the unlock. So we'll do that. Now let's try and do an unlock. So now, so it did the unlock. And now it's actually doing a refresh and all that, kube control, or list images. So now it's pointed to that one. So it looks like, okay, so the upstream URL, so upstream URL means the connection to Weave Cloud, okay. So it looks like, and this is the thing that's confusing me, and maybe I'm wrong, maybe the documentation's wrong, but it says, so I'm locking a controller, I think also means that it won't apply any changes that you make manually, even though it says changes made in the file will still be synced. So it could be a bug going on there. But the other thing is that, you know, if there is a mode to actually put an annotation on a deployment that says, hey, if you make changes to this in Git, just don't do anything because I want to make sure that I freeze this one. I want to apply that not just to controllers, I want to apply that to other things too, right? So you know, there's this, I think there's this idea of what are the objects that that Flux is pushing, and then what are the objects that it knows how to manipulate and deal with, like controllers. So I think controllers are a subset of the objects that Flux deals with, and doing something like the freeze might be something that you want to do directly on the object. But all right, so that looks really interesting also. Okay, and then there's ways that you can, let's see, issue a deployment change result in version of the control. So that's awesome. We saw that. There's flags on the daemon so that you can change all of this stuff here. And then it says, when building images, it is often useful to tag build images by the branch that they were built against. Okay, so you can set a policy here that says, oh, I only want to look at the tags that, okay. So you could do something that's somewhere along the lines of like, oh, it has to begin with 1.3 dot star or something like that. So you know, even if it's not, and you can do that on a per pod basis versus all. Okay, so that's pretty cool. I mean, on a per image basis versus all. So even if it doesn't totally, totally doesn't go through and understands, you know, Semver, I think it's still, you know, you can get a lot with this globbing. Weave Cloud UI sends user parameter value, which is the username of the user logged into Weave Cloud. Okay, so the upstream service does stuff. And then actions filtered through fluxctl. So fluxctl provides the following flags for the message and the author customization. So you can actually specify what users you want to use and all that stuff, the commit author. All right. So this all actually makes sure that the Git history actually looks good. That's super cool. All right, well, cool. All right, so I am going to wrap up. I think that's a good intro to how Flux works. Looks like a super cool tool. Let me switch back to my face here. Yeah, the tag policy definitely seems like a really interesting thing. So my impressions here, I am worried about the security of this stuff. So I think, you know, this suffers from some of the similar concerns that I have around Helm, in that there is there's a port that, as far as I could tell, doesn't look to be authenticated, that lets you manipulate things in a meaningful way. So that's something that I would worry about. I would really look for some sort of authentication for this. I think there's some lightweight ways to do this. I think one thing that could happen is what you could do is you could, when if you just want to do some level of authentication, you could go through and have the Flux daemon, when it create a token, store that in a secret, and then anybody who has access to that secret can then be used as, you know, communicate to that, and then use TLS on top of that. So you could do some stuff with that. I think that would be really cool. Being able to run this stuff on a per namespace basis would also be super, super cool. And then the last thing is that as we see a richer set of tools that play with application definition, having an extensible model in Flux so that they can interoperate with those tools, both in terms of, hey, you know, when you want to actually get the YAML, maybe like the YAML is not stored directly, but it's derived from stuff that's totally in the Git repo. There's different sort of philosophies on that. But then again, when you're manipulating this stuff, sometimes you don't want to manipulate the YAML directly. You want to manipulate some other file that then knows how to actually have that stuff come through. So having some sort of extensibility mechanism for saying, list me all the components, list me the images in those things, and then being able to modify those. I also think that as we see CRDs, Flux can go through and push CRDs, but there's going to be things that you're going to like. There's going to be places where you're going to have an image name in a CRD, and so the set of controllers will be extensible also. And so I think that's going to be a challenge as we get a richer set of CRDs that may actually include controllers to actually have Flux be able to deal with that in a flexible way. Not an easy problem at all. And then Ilya says that we are looking how it would work with generators. Yeah, so I think that's definitely a challenge and super cool. Yeah. All right, well, thank you so much, Ilya, for joining us. I know that it's late there, and I really appreciate you taking the time. I think it was definitely, it's always great when I do these things to have somebody actually knows what they're doing, that actually stays on the line and helps answer questions. So if you liked this, I'm going to sign off right now. Please hit the subscribe button. If you want to be notified when we schedule new things or when things are happening, there's like a bell that you can put there also that says I want to subscribe to notifications. Other than that, let's see. I have a lot of ideas for TGIK, but I'm going to start handing this stuff off to Kris more and more. I think Kris is going to be doing more and more of the TGIKs. Some of the other duties that I have here at Heptio, Chief Keyboard Officer. Those things are getting taking more and more of my time, and so I'll find a way to work with Kris and find the right schedule so that we can both still participate, but but it doesn't take up so much of my time. So look forward. I think next week I'm definitely signing Kris up to do next week. So look forward to TGIK from Kris next week. And thank you everybody for joining me, and have a great night / morning / weekend. And I'll see you all later.